அகற்றும் பணியில் ஊழியர்கள் போர்க்கால அடிப்படையில் ஈடுபட்டுள்ளனர். புழல் ஏரியில் நீர்வரத்து 1500 கன அடிக்கு மேல் இருப்பதால் அணையின் பாதுகாப்பு கருதி 2000 கன அடி வீதம் உபரி நீர் வெளியேற்றப்பட்டுள்ளது. கரையோரம் வசிக்கும் மக்கள் பாதுகாப்பான இடங்களுக்கு செல்லுமாறு மாவட்ட நிர்வாகம் சார்பில் அறிவுறுத்தப்பட்டுள்ளது. திருவள்ளூரிலிருந்து இயக்கியது.
Hi Ani.
Hi Janakiraman.
So that was telling us that there is heavy rain in Chennai.
Yes,
in and around Chennai.
We are able to see it outside.
And you can see that you don't need the radio to tell us this.
Yes.
But I thought we should, just look at the radio because we were talking about wired communication, and next we wanted to talk about wireless communication.
That's right.
So current generation is so used to mobile phones and other things, and the reason we wanted to start with the radio is that communication dates back to much earlier times.
That's
where
right.
technology was not as sophisticated as what we have with our mobile phones.
It's more than 100 years old now.
Exactly, right? What, invented by who? Marconi?
Yes, that's
Right?
right. Marconi
Exactly.
and Jagadish Chandra Bose.
Jagdish Chandra Bose, exactly, right? So this is a sort of the techniques are actually quite similar today, even today with your wireless mobile communication, Wi-Fi and Bluetooth and all that.
That's right.
So I thought we should look at the most elementary form of wireless communication first, right? And that's why I brought this radio with me.
Absolutely.
Okay, and right. So let us see what we have here. I'm just so that the users can also see this. What you see is
ஜப்பானில் நடைபெற்று
What did you change?
So what I did there was I switched something called the band. Okay, there are two things. So you will have to explain and help me understand them. There are two things here.
Okay.
One, it says FM and other is AM.
AM.
Okay.
Okay.
Yeah.
Okay. So, there are two ways of sending information
Okay.
in a radio.
Okay.
In wireless fashion.
Yeah.
So let us go back to the sinusoidal representation that we have seen.
Okay.
Right. So we'll say that this signal, let's say we'll call it M of t,
Okay.
is our standard representation in terms of the amplitude, the frequency and the phase.
Phase. Okay.
This is the most general form
Okay. Of a sinusoid.
of a
Yeah.
sinusoid.
Right.
And a lot of information theory is based out of, and electrical engineering is based out of consideration of sinusoids.
Right.
And when we want to send information, we are looking at sending information using sinusoids.
Right.
And as you can see, there are 3 parameters that specify this particular sinusoid. And I think we have actually plotted and shown all of them.
Yeah.
Now, by now, the students know that you have the amplitude,
Okay.
you have the frequency,
Yeah.
and the phase. We'll look at the first two.
Okay.
Turns out that you can send information
Okay.
by via a sinusoid
Okay.
in terms by changing its amplitude or changing its frequency or changing its phase.
Okay.
So what you are looking at in the radio, when you say you changed it, you said that switch changed it from AM
to FM.
to FM. So this would be called AM radio, would use the amplitude to send information,
Okay.
and the FM radio would use frequency.
Okay.
information.
And the M stands for
Modulation.
modulation.
Yes.
Okay. Amplitude modulation and frequency modulation.
And frequency modulation.
Wow. Okay. So I again
Nice.
so
I see several other knobs there.
correct.
Right?
Right. So if you look at this, right, first of all, it says for FM, it gives a certain frequencies on top
And it says megahertz, so clearly it's frequency.
in megahertz,
megahertz.
right? For AM, it gives another set of numbers, but it is in kilohertz.
Kilohertz. Okay.
Right?
Yes.
So, can we just note down those numbers
yes.
first? What
I
are the
believe,
frequencies?
I believe FM goes from 530 kilohertz,
Yes.
if memory serves me right,
Absolutely.
to about 1600 kilohertz.
Absolutely, you're right. This is exactly what we have here.
1600 kilohertz.
So, what I have tuned myself here is I have selected AM
Okay.
and I'm somewhere near 660 kilohertz.
660 kilohertz. Okay. So we have tuned. I am using the word tuning because I know we used to call it tuning the radio.
Exactly.
Right?
Right?
So I'll just say tuned
to 660 kilohertz.
660 kilohertz.
Yeah. Right?
Okay. And you said AM radio was megahertz. If I remember correctly, sorry, FM radio.
Yes.
FM radio was some 88 to 108 megahertz is what I remember.
Exactly.
Is that right?
87 to 108.
87 to 108
Megahertz.
Perfect.
Okay.
Okay. And you had tuned to what frequency?
Yeah. So in FM, I again come back. It is near
90?
89 or something.
89?
Oh no, 91.
91.
Right? Right?
I'll say approximately, yeah. It's
some 91
megahertz.
megahertz.
Correct.
Okay. So, so essentially we are tuning this radio to receive signals at different frequencies.
Yes, that is right.
Right?
So, I guess because we are talking about radio,
Yeah.
it's a one-way form of communication.
Yes.
Because there is a station somewhere that is broadcasting music.
Right.
Or,
Right. The news.
or
right.
something else.
Okay.
And we are receiving it.
Yes.
And, you can find out, for example, All India Radio has a few bands that they use. And there are some commercial, AM radio, FM radio bands as well.
Yeah.
Once you know which frequency they are tuning, you can tune your radio to that frequency and listen to the news, music, whatever.
Right?
That's right.
Okay. So there is essentially a radio station which is like what, couple of kilometers away?
Probably a couple of kilometers,
Right.
Maybe 4-5 kilometers away.
4-5
I know there is one on Marina Beach, if I'm not mistaken. There's an All India radio station.
Right.
I know at least one.
So I think that's like that huge tower. That
huge tower.
Right. That
That's
is going
right.
to okay. So now what is the typical distance that I can, pick up these signals?
Okay.
AM and FM.
So to do that, we have to look at the frequency.
Yeah.
And the mode of communication.
Okay.
So normally, if you look at AM radio, so there are two things that will affect how far away you can be to receive it.
Okay.
The first thing is the power being transmitted at the radio station.
Right.
The second is the mode of communication.
Okay.
There are some wireless signals that bounce off the certain layers of the atmosphere. For example, I remember 30 years ago, people used to receive shortwave radio from Sri Lanka.
Yes.
It is definitely most likely not line of sight.
I think that's here.
Is that there?
SW1.
That's right. There you go. That's SW1, a shortwave radio. Most likely it is reflecting off some...
and the band is 2.8 to 10 megahertz.
There you go.
That's
That's right. That's why it was called shortwave. Because AM radio, being in the order of few hundreds of kilohertz, the wavelength is related to the inverse of the frequency.
Okay.
Because this frequency is low, the wavelength is very long.
Okay.
And 10 megahertz is shorter wavelength corresponding to this.
Right. Okay.
So it typically reflects off some particular layer of the
ionosphere or something like that.
Or something, and then comes back down.
Okay.
You can hear it.
So essentially, you could have your radio station here, and you could have, so maybe if you can just draw the earth.
Yes.
Right.
That's a good picture to see.
Yeah.
So normally, if I just show the earth.
Yeah.
This is the earth. And if you imagine that you have a radio tower, I'm going to show this antenna in this fashion.
Yes.
So normally what happens, your radio waves can actually bend around obstacles. They can travel through space.
Yeah.
However, there is a limit to which they can do that. They can bend around obstacles, but you normally still require, there is a range till which you can easily receive the signal.
Right.
Obviously, the taller the tower, the larger the range that you can receive, as you can see.
Yes.
Right?
Yeah.
And which is why you see broadcast radio on taller and taller towers.
It's a huge tower, right?
Huge towers.
Exactly.
You can go to, you can see further down the horizon. You can send the wave further down the horizon.
So this is also just trigonometry, right?
This is just trigonometry.
Just how far you can go, you just draw a tangent there.
And that's it.
Okay.
Okay. Now, shortwave radio, however, is using something different. So what I'm going to do, let me say, I'm going to show let us say some portion of the atmosphere.
Some ionosphere or something.
Some ionosphere or something. But let's say some layer of the atmosphere.
Yeah.
And it is possible for you to, for example, reach something really far away by actually reflecting off some portion of the atmosphere and go further than what you could actually do.
Okay.
So, which is what shortwave radio was exploiting.
However,
you can't do this for every signal. Because that particular layer of the atmosphere, the ionosphere, reflects only a certain range of frequencies, unfortunately.
Okay.
So, maybe a few tens of megahertz is pretty common.
Okay. So effectively you're saying, okay, that means from what I see, FM will not reflect.
FM will most likely not reflect. You're limited to, what you might call line of sight. Even though it is not true line of sight because it can bend around obstacles.
Yeah.
But you are limited
by
the horizon.
So it's about you stand on top of that tower. What can you see?
Exactly.
Assume
that everything is flat.
What can you see
what you can
up to that point, right?
That's right.
So therefore the FM reception should be like what distance should be?
So the FM distance would probably be FM distance can actually be quite long. It can actually be maybe 10 kilometers. It can be longer than AM.
Longer, right? Yeah.
Absolutely. It can be longer than AM. So it can be maybe 10, 20 kilometers easily.
10, 20 kilometers.
That's right. That's right.
Okay. So that's why when we drive out of the highway from Chennai, you can tune into the FM of Chennai to a certain distance then you're done.
That's right.
Right?
That's right.
Okay. Interesting. Okay. So, there's something else here which is also quite intriguing.
Yes.
I mean, I just pulled this out. It appears quite tall. So, what is this?
So, this is actually the antenna of the radio.
Okay.
So, I think we just told them that this antenna is on top of this tower, which is radiating. You also need an antenna to receive.
On your receiver.
That is on the transmitter, this is on the receiver. Turns out it is the antenna that converts your voltages and currents inside the device into an electromagnetic wave.
Okay.
So it does the reverse. So on the transmitter side, it converts voltages and currents into electromagnetic waves.
Okay.
On your personal radio, it converts it back.
So
this is basically a piece of metal normally in a very specific shape.
Okay.
Right. Older people might know, TVs have antennas, used to have a very specific shape called the Yagi antenna.
Yeah.
Right. So that used to be a very specific shape. And there are various types at high frequencies, people use focused antennas called horn antennas. You have parabolic reflective antennas and so on. You have various types of antennas.
Right. So even the antenna that we use for satellite TV.
Exactly.
That's like a dish. It's a dish antenna, right?
That's right. It's a dish antenna.
Okay. So effectively, this is what allows us to receive that signal and get it into our device.
Absolutely.
As an electric signal.
Absolutely. So the reason, if you actually use this, when you are further and further away from the AM radio, here we are actually quite close. If you are further away, if you extend out the antenna, you will actually receive a better signal. It will pick it up better.
Right.
Here, probably you will not see such a big difference. Maybe we can turn it on and see.
We can see, right?
Is this an FM or AM?
This is FM.
Let's go to AM because AM, as we saw, the frequency is lower.
Correct.
So you probably need the antenna.
Yeah. So here it's not.
There is very little difference.
Very little difference because we are quite close.
Correct. And you can try FM as well if you want to be sure. But I highly doubt if.
Yeah. So I guess the best place to try this is when you're driving out of Chennai.
That's right.
Your signal gets weaker and weaker. That's when you need to pull out the car antenna. Right?
Absolutely.
And that's when it will make a big difference to your reception.
Absolutely.
Right? Okay. So